Right, question 17. Blue paint and yellow paint are mixed together in a ratio of 2 to 1. So that means that I've twice as much blue as I do yellow. Draw a graph that can be used to work out the amount of yellow paint needed given the amount of blue paint. Your graph must show up to 10 litres of blue paint. So here's my blue paint. Okay. Right. I think what we're going to do with this one first is, let's lay out carefully. We've got blue, we've got yellow, and then we know that if blue is 2, yellow is 1. So I could also say that if blue was 4, yellow would be half that. If blue was 6, yellow would be half of that. If blue was 8, yellow would be 4. If blue was 10, yellow would be 5. I'm not going to go any further than that because I can see on my graph here blue only goes up to 10. So there's no point in me going any further. And also, it's going to end up being a straight line. And I know already that I only need really 3 points to do a straight line. So I've got plenty on this. What gets a little bit tricky probably is over here. They haven't actually given us any values along this yellow paint axis. So I'm going to take a look at this and think, right, if I do 1, 2, 3, 4, 5. So 5 would only take me up to here. I'd rather stretch it out a little bit more. So maybe if I do these double boxes, 1, 2, 3, 4, 5. That would work nicely. Spreads my date out a little bit more. So that's 1. These boxes go up in tens. So that's my 2, 3, 4, and 5. Next thing to do is take my ruler and pencil and let's mark off some of these. So when blue is 2, yellow is 1. So let's go across 2, up 1. Across 4, up 2. And let's do 1 here at the end. Let's do 10, 5. So 10 up to 5 goes there. And relief, I've got myself a straight line. Just to check now, 8 should be 4, so if I go 8 up to 4, there's my 4. So I'm pretty confident with that. And just to know, if I had no blue paint, half of 0 would be 0. So it does need to go through 0, 0 like that. It's important you do mark it off there. So that bit was just draw a graph. So that's done. Yep, that's all good. How much yellow paint needs to be mixed with 9 litres of blue paint? So 9 litres of blue paint. Here's my 9. So I'm going to have to do is go from 9, hit the graph, or hit the line I should say, and go across to see what my yellow would be. It's important you're showing the examiner that you're using this correctly. And this here looks like it's 4.5. So I need 4.5 litres of yellow paint. Question 18. The perimeter of a triangle. So perimeter, I've added together the 3 sides. So something plus something plus something gives me 27. The length of each side in centimeters is a prime number. So actually, before I go any further, my prime numbers now, they're 2, 3, and I might have written this down in my first 5. 5, 7, 11, 13, 17, 19. I'm going to do 2 more, I think. 23. And 25, 26, 27, 28, 29, 29, but I don't think I'm going to need 29 because they need to add together to give 27, so 29 is definitely too big. So these should be the prime numbers that I'm using. Work out the lengths of the sides of a possible triangle. So this might take a while, a little bit of trial and improvement. So I'm thinking here, I've got a 7 there. So if I use 7, I know these two need to add to 20. So a 20 here from these numbers. Pretty boring actually, I think I've got it already. 7 and 13 add together to give 20. So those three add to give 27. Does it say that they're all different? The length of each side in centimeters is a prime number. Work out the lengths of the sides of a possible triangle. It says a possible triangle, so I just need one. It doesn't say that they have to be different, so actually I've already got it. That's my answer. 7, 7, 13. There would have been nothing wrong with it if you'd gone through this, taken you a while. So for example, 23 plus 2 plus 3. If I added those together, it gives me 28. That doesn't work, so I try again and then hopefully eventually get that. There might actually be a different solution, a second one, but mine works perfect, so I'm happy enough with that. 19. An allotment has 2 planting beds, available for vegetables to be sown. So we've got plot A, plot B is a little bit bigger. Each carrot needs at least that much of floor space. So what that means is that if I did, for example, plot A, it's got that much space, 4 meters squared. So if I did 4 divided by 0.1, I could plant 40 carrots in plant A. That's what that means. If I did the same idea on plant B, 7 divided by 0.1, I could do 70 carrots in plant B, so a lot more. Each cauliflower needs at least that much floor space. So that needs even more, so I'll be able to plant less cauliflower than carrots. Show that the total number of vegetables to be grown is larger, so the total is larger if you put the cauliflowers in plot A and you put the carrots in plot B. So we're going to have to do a little bit of working out on this, see how many we can get into each and what is the best solution for all. So I'm going to lay it out like this, I think. A, B, I'm going to do area here. So the area for A is 4 meters squared. For B it is 7 meters squared. If I did then maybe something like this, where I work out maybe just the carrots you can get in each. And then down here I could do the cauliflower you could get in each. So the carrots for A, we worked it out already actually. We did 4 divided by 0.1 and that came to 40 carrots. B, I believe we worked out earlier as well. We did 7 divided by 0.1 and that gave us 70 carrots. The cauliflower we haven't worked out yet, so we'll have to do that. We got 4 divided by 0.6. Well, that's nasty. So that's going to be 6.6 recurring. Not very nice that they gave us that question. And the next one, B, it'll be 7 divided by 0.6. And again, I have no idea what have given us these nasty numbers. 11.6. So for the cauliflower, what we can't do here is we can't grow 0.6 recurring of a cauliflower. So on this one, we're going to have to round this to 6. And for this one, we're going to have to round it to 11. Because we only want to grow full cauliflowers. We don't want half a cauliflower or 0.6 of a cauliflower. So they're the totals that I could grow in each. If I go down here to a total column, so if I did, let's say, we grew the carrots in A, so carrots in A, that would be 40. And if we did the cauliflower in B, cauliflower in B would be 11. We get a total of 51 vegetables. If we did vice versa, if we did carrots in B, carrots in B is 70. If we did cauliflower in A, that'd be 6. So my total vegetables would be 76 vegetables. It said show that the total number of vegetables to be grown is larger if cauliflowers are in A and the carrots are in B. So it's that bottom option there, you get 76 vegetables. We've shown it, so there's nothing else we need to do with it. Work out the next term of this quadratic sequence. So always when you get a sequence, check, right, what's it changed by each time? So for this I'm adding 1. To get from 6 to 9 I'm adding 3. Now I'm adding 5. So you'll see with the difference, that changes by the same amount each time as well. I add 2 to the difference every time. So the next time I'm going to add 7. 14 plus 7 is 21. 21 is my answer. Important to show these bits as well, given it's 2 marks. So if you're recognizing these, you're picking up a mark straight away. 21. Circle inequality shown by the diagram. So it's between 4 and 3. So yeah, they all have minus 4 and 3, so that's correct. This empty circle here means that it's not equal to minus 4. So it can't be this one, because that says are equal, so it's definitely not that. Can't be this last one either, because this has the are equal as well with the minus 4. Over here it's got a solid circle at 3, so it could be equal to 3. Which means it can't be this one. And that leaves us with minus 4 and the 3 here. (21a) factorize. So factorize sounds like factors, and I need to put it back into brackets. Factorize fully, so we're going to make sure we take out the highest common factor every time. So underneath it, open up your brackets. 10 and 25, well, 5 divides into both of those. A squared and A divides into both of those. Now I'm thinking 5 times something is 10. A times something is A squared. And then lastly, 5 times something is plus 25. That would be 5. 5A times 5 is 25A, so that's correct. Part B, solve. So we're going to have to probably think about using our to-do methods or inverses here at some stage. This is a quadratic, so the first thing I want to do is put it back into double brackets, so factorize it. So I'm thinking here, you've got x and an x, and this next bit, I'm going to look at the factor pairs of minus 15, which add to give it 2. So minus 15 and 1, they add together, you get minus 14, that doesn't work. If I did 1 or minus 1 and plus 15, that gives me a plus 14. If I add them together, not plus 2. The other factor pair is 3 and 5. If I did minus 5 and plus 3, that gives me a minus 2. So that doesn't quite work. If I do minus 3 and plus 5, if I add these two together, they will give me plus 2, so that's what I can use as my numbers. It doesn't matter which way around they go, as long as the 5 is positive and the x is negative, or the 3 is negative. Lastly, that was the hard bit. Next bit, x minus 3 is equal to 0, and do x plus 5 is equal to 0. But minus 3, if I add 3 to both sides, x must be equal to 3. If I take 5 away from both sides here, x must be equal to minus 5. So my answer is 3 and minus 5. Question 23. In a school, 60% of the students are senior. Just looking ahead or skimming ahead, I can see you've got seniors and juniors. So what I'm going to note down now, if 60% of them are senior, then the rest of them, 40%, must be junior. 45% of the seniors have school meals. So that's 45% of 60%. 75% of the juniors have school meals. So that's 75% of 40%. What percentage of the students, so it's only looking for a percentage, it doesn't want to know how many are senior, how many are junior, etc., etc. It's just a percentage. What percentage of students have school meals? So this is tricky if you think of these as percentages, but it wants our answer as a percentage. So actually, the number of students that are senior, the number of students that are junior, we can give it any value we want, because we want our answer to be a percentage. Doesn't matter how many are senior, how many are junior, how many in total, the proportion will be the same. So what I'm going to do is, I'm going to assume that there's 100 pupils altogether. You don't have to use 100. You could use 1,000, 200, etc. But 100's easy, because now I know that my seniors, if there's 100 in total, there's 60 seniors. If there's 100 in total, there's 40 junior pupils. I need to get 45% of 60, and I need to get 75% of 40. So 75% of 40 is easy, that's 3/4 is 30. 45% of 60, let's do 60 divided by 100, that's 1%, multiply by 45, we get 27. So 27 of the seniors have school meals, 30 of the juniors have school meals. What percentage of all the students have school meals? 27 plus 30 is 57. Out of 100 have school meals. That's obviously 57%. So again, the key there really was giving the total an arbitrary value, whether it's 100 or 200 or whatever you want to choose. 100 is probably the easiest when you're dealing with percentages.